The idea that the ocean is blue because it reflects the sky is a common misconception, though widely believed. In reality, the ocean's distinctive blue hue comes primarily from how water molecules interact with sunlight through absorption and scattering processes. While the sky's reflection can contribute to the effect under certain conditions, is a secondary factor. The fundamental cause is water's intrinsic property of scattering blue wavelengths of light back to our eyes, while absorbing longer wavelengths like red and yellow, a phenomenon that would occur even under a gray sky or in a laboratory setting with no sky reflection at all. Let's dive deeper into the physics behind the ocean's color. Sunlight contains a spectrum of wavelengths from about 400 nanometer to 700 nanometer. When this light hits water, two key processes occur: absorption and scattering. Water molecules selectively absorb longer wavelengths, particularly red and yellow, much more efficiently than shorter blue and violet wavelengths. This selective absorption isn't random but relates directly to water's molecular structure. The oxygen-hydrogen bonds in H2O vibrate at frequencies that resonate with infrared and red light, converting that energy into heat. By 10 meters deep, most red light is absorbed. By 100 meters, almost only blue light remains. The blue light that isn't absorbed undergoes Rayleigh scattering, where light bounces off particles smaller than its wavelength. In this case, water molecules, which is about 0.1 nanometer across, versus light's wavelength. This scattering efficiency follows a 1 over lambda to the fourth power relationship, meaning shorter wavelengths scatter much more intensely. Blue light scatters approximately 10 times more than red light. While this scattering effect is much more dramatic in the atmosphere, creating our blue sky, is more subtle in water, where absorption dominates. Yet, it still redirects enough blue light back to our eyes. The numbers make this clear. Pure water's absorption coefficient at 450 nanometer, which is blue, is about 0.015 per meter, meaning only 1.5% of blue light is absorbed per meter. At 700 nanometer, which is red, it's about 0.6 per meter, 40 times higher. Following the Beer-Lambert law, this exponential difference means that at 50 meters depth, red light has virtually disappeared, while blue light persists. The sky's reflection contributes to the ocean's blue appearance but isn't the primary cause. On a clear day, the blue sky may reflect off the surface, enhancing the effect by perhaps 10 to 20%, depending on viewing angle and wave conditions. However, laboratory experiments with water in controlled environment without any sky reflection still demonstrate water's inherent blue coloration. Other factors can influence ocean color in specific locations. Phytoplankton or suspended sediments can shift shallow waters towards green or brown hues. Nevertheless, in the ocean, deep ocean, the combination of water's absorption spectrum and Rayleigh scattering consistently produces the characteristic blue we associate with the seas, a natural consequence of physics rather than merely reflection of the sky above. Thanks for watching. If you found this video helpful, Give it a thumbs up and don't forget to subscribe to the channel. Let me know in the comments what other topics you'd like to see covered, or if you have any additional tips to share.